everyone. My name is Alex Benzell. I'm a scientist at Nimbus Therapeutics, and I'm here to talk today about how we use Spotfire and use it to assess external resource KPIs and design solutions to streamline drug discovery programs. So, a bit of an agenda, talk about Nimbus, who we are, what we do, how we typically use Spotfire as a workhorse day in, day out, but also a lot of the really cool things that you can do with Spotfire, visualizations, bringing in multiple data sources and how you can use the data you have and use those types of visualizations to enhance your research efficiency and how we're doing that at Nimbus. So, bit of a background at Nimbus. We have one parent organization called Nimbus Therapeutics, LLC, which wholly owns each of our program-focused subsidies. So over on the left, you can see a lot of our historical subsidies, that many of which have been partnered or exited, such as, our recent acquisition by Takeda of Nimbus Lakshmi. But also on the right, you see our active discovery programs. And then below all of them, we have Nimbus Discovery, which incubates and houses a lot of our newer stuff that isn't fully on a program level yet. So Nimbus is a completely virtual biotech in the sense that we don't have any labs. We work very closely with our CROs and partners to do research all around the globe. We refer to it as our distributed resource model. So all the way from discovery to preclinical and development, we're utilizing CROs all across the globe. We have about 81 FTEs internally, but we have over 300 contributors who are helping us bring new medicines to patients. So how we currently use Spotfire. So in the past, we've talked about how we used it for looking at chemistry data sources, from Chemble, our own internal data sets, other data sets that we've purchased, to get an enhancement or view of SAR, because something that's really great about Spotfire is that it's chemically aware. So we've also used it to see our own efficiency for software, who's using what software, how much, which departments use what, as well as how do we, communicate and govern that in the sense of what's the best way, who's using what, and how can we make business decisions that streamline everything. But as I alluded to on the previous slide, what else do we need to streamline that's important to us? And one of the big things that's important is how we do our research. So because we're completely virtual and we don't have our own labs, we rely on our CROs tremendously. But we can't just go into the lab and see how something's going. So what are other ways that we can look at how well and how smoothly our research is occurring in this distributed resource environment? So that's what I'm going to talk about next, because it's just so mission critical for us as it is for other companies out there. So I'm going to present a few cases, the problems we had, how we found them, and what we did about them to resolve them. So a bit of background first, our automated workflow for how we load data, because this will be a bit important for looking at some of the cases that we have coming up. We use a system we've designed called Nimbus, which is a way for us to easily work with and leverage our main SharePoint or file sharing service called Ignite. We have CROs deposit data into our Ignite shared area. And then every 30 minutes, AWS, it looks for new files, it pre-processes them, and is able to put them into a format that loads into our database, where the data can then be visualized by project teams through a variety of tools. We use something called Jira, which tracks all of this. And with that, Jira associates metadata with each experiment, and each data file is an experiment, and Jira loads certain metadata associated with that. And with that metadata, we're able to then take a look at things and say what's working, what's not working, and where are, and just look at the metrics around the data that we have loading. But if we start to combine this with our other data sources, we can really start to get a picture of how well things are working under the hood. and where things aren't working, we can design targeted system and workflow enhancements to result in streamlining drug discovery, which is exactly what we've done. So in our first case, we look at just data upload as a whole. And this is something that happened a bit last year. We were having a systemic issue with being able to load data. So on the charts here, we see how many data files we had to load per quarter. And green means it was a success and able to load without an issue. A red means that there was QA. There had to be manual intervention to get data to load. And when there's manual intervention, that means we have scientists who aren't doing science. They're doing data formatting, which is not what we want them to be doing. That's not an efficient utilization of resources, whether it's our scientists or CRO scientists. So we took a look further at this and said, well, in these, where aren't things working? We're only getting more and more data, and it's not going to get easier. It's not something that's going to go away. So what can we do about it? So some of the first things we did are look at what are the most common problems and where do those problems fall, in the sense of, is it a Nimbus problem or is it something that we should work with our CROs to fix? And the result was, it was a mixture of both. Some of the biggest types of errors we had are if data fields aren't correct or if there are compound ID errors. And we said, hey, these are things that we should be prepared for ourselves. We should not be, we should not be stumbling over ourselves to not load data for these specific issues, because that holds back project teams. So we put in some proactive workflows that said, hey, if we ever want to do something new, we got to get everything set out in advance. We need to get the red carpet rolled out for it, essentially. And that's exactly what we did. And you can see that, between Q2 of 2022 and Q2 of 2023, we were able to load significantly more data, and a lot of our common errors were going down, which was something that was seen on the previous graph. We went from about, 80% success to marginally over 90% success. That's, and that was big for us, especially as we load more and more and more. The other thing that's very important is working with our CROs and our partners to also do this. It's not, none of what we do can just be put on one person's shoulders. There really has to be a back and forth. So working with CROs to help mitigate some of the other errors that were coming up, was hypercritical to this, and their collaboration is essential. But because we were able to and the reason we were able to do this was because in Spotfire, we were able to look at, all of our data loading globally and say where things weren't working, where things aren't working. We were able to see a much larger increase across the whole front. But in the next case, we look at some more, targeted things targeted issues that we tried to tackle. So in the next one, we were looking at data upload times in the sense of how long does it take between when an experiment is done and when scientists are able to view the data for it. And in screening campaigns, efficiency is a necessity. And metadata from our Nimbus data upload system help identify bottlenecks that our scientists were experiencing. They were noticing that for one CRO for a particular program, it was incredibly variable how long it would take data to become available after the experiment was completed and compounds arrived there. So over here, we can see that, just starting out working with this new vendor or working with this new partner, that upload times were very variable, somewhere between 1 day to almost 4 days at times, which really, causes stress and issues for project teams. So we took a step back and said, well, what can we do about it? So we started working internally to automate a lot of the data analysis that they were doing. They use Excel very often, so we help them employ and start using Excel fit templates. So that way, when data and information comes off a plate reader, they've got a set up plate map, and all the formulas can go out and get us the data that we want quickly. It gets us the KIs or IC50s or EC50s that we need and in a format that we want, so that way project teams can view this. And in just the period of a month from implementing this at the beginning of 2023 to even just in April, we were able to dramatically reduce turnaround times from almost 4 days to really going steady at about 1 to 2 days. And it's been durable since, and that's been very important to this project team. Afterwards, we started looking at that and saying, well, what else can we do if we start looking at upload time and experiment turnaround time? And so we started to look at some less routine, less frequent, but still very important types of experiments, and said, we're doing these at 2 major, CROs. What can we learn about where things are working and where things are not working? What are other ways that we can visualize this? So for one particular set of experiments, what we did was we took the median days to upload and we binned them. We binned them in bins of 1 from 1 days to 10 days, and then anything 10 days or greater. In terms of how long does it take to turn around and get the data back to us. And we settled on greater than 10 days because after 10 days, the extra resolution of how long it takes isn't as material of a difference. And what we can see here is that looking at CRO A and CRO B, CRO B is very good at turnaround times. They're very good at getting things to us within really 1 to 5 days. Whereas CRO A, really, they're not in that space. They're taking usually 10 days or greater. A few times they've been able to be faster. But for the most part, CRO B is really in that 2 to 5 day period. So while we did start taking more looks and more steps at, well, why is this going on? In the meantime, we also had to make a decision and say, waiting over an extra week for data is a lot of lost time. But it prompted a serious reassessment of where do we want to do this type of experiment? And where can we make sure that we're also able to get faster turnaround times, as well as not being over leveraged in terms of doing all of our resources, all of our experiments for all of our programs at one place. In case 3, we looked at efficiently balancing chemistry resources. So in this situation, a high-profile program needs to deliver a development candidate on a set timeline. With a finite budget, how do you split your chemistry resources while also managing your CRO risk? One thing that we've all learned a lot is, it's very important to spread out where you're doing your work while also maintaining your efficiency, which is why having these dashboards is so important. So we look at a variety of metrics to understand how our chemistry is going along, going all the way from reactions per day to successful reactions per day to, bottom line results of how many compounds are we getting per, dollar or resource over at a partner. And over here, we have 2 different CROs working for the same program doing similar types of chemistry. And we can see that one, CRO E, is, very strongly outperforming CRO F, which is the green line below. And so what we're looking at here is compounds delivered per FTE over a monthly period from May 2022 to May 2023. And one of the things important to note here is we do account for some noise in terms of, so in this particular place, CROE has done some different types of chemistry that made their numbers seem higher and more elevated. But, for some of the latter months, that hasn't been the case. So we were making sure that our comparisons were apples to apples. And what we ultimately found was, well, maybe we should balance our resources, move some chemists and FTEs from CRO F to CRO E. So that way we can still maintain chemistry, maintain efficiency, and also get what we need to be able to deliver for our program, which is what we did. And just balancing a couple of resources or a couple of FTEs from one to another led to a from one CRO to another led to a substantial increase in terms of the amount of new chemical entities that we're registering and screening in this program. So on the left, we have count of lots that we've registered per month for the total for this program. And we did that shift in the summer of 2023. And you can see that we've been able to scale up and just increase the amount of chemical matter we're able to screen, which is important because more chemical matter screened means you can get to your DC faster. You've got to get through that chemical matter to get there. Ultimately, when it's no matter what you're looking at, or these cases, whether you're looking at, biology or data or chemistry, we were able to get these visualizations and be able to improve on our research efficiency because of how we could bring everything together in one place in Spotfire. And it wasn't easy. There's a lot of moving parts to being able to just open up this dashboard or open up this Spotfire template and look at anything you want and slice it and dice it the way that you need. So there's a few people we really do need to say thank you to. One of the biggest is over at Nimbus Therapeutics, our head of IS, Rebecca Carraza. Also, a lot of our consultants as well. This is not, all easy for us. And we do need help. So I'd like to also thank our consultants, particularly John Kinney of Workflow Informatics, who has helped us a lot through this and setting up a lot of these Spotfire visualizations, plus Philip Chung and John McNeil. We'd also like to thank Revity Signals and, Chris and Tanya for, inviting us to speak and talk about this amazing stuff that we're doing with Spotfire over at Nimbus.